now let's look at another interesting problem, right? It's a different because it's a different problem because it's a word problem. So here they are saying given the area of a rectangle is 16 raised to the power of x minus 100 centimeters squared, and the breadth is 4 raised to the power of x plus 10 centimeters. Now they are saying determine the length of a rectangle in terms of x, right? So it's always best to draw a scenario so that you are able to see what really is happening, right? So you have a rectangle. So we have a rectangle here, right? And they are saying the area of it, right? So the area of this rectangle, which is here, everything in here, the area is 16 raised to the power of x minus 100 centimeters squared, right? And then they're saying the breadth, right? The breadth, so this is going to be your length, right? And then this is going to be your breadth, right? So they're saying the breadth is equals to 4 raised to the power of x plus 10. So you write the breadth. So you have 4 raised to the power of x plus 10 centimeters. So this is what you are looking for, right? So the formula of an area of a rectangle is area is equals to length times breadth, right? You already have the area, you already have the breadth, right? You have area, you have breadth, but you are looking for what? The length. So we are going to try and substitute and solve for L, right? So the area is 16 raised to the power of x minus 100 equals to length times 4 raised to the power of x plus 10, right? So what we are looking for is the length, right? So we are going to try and divide by 4 to the power of x plus 10, right? What we do on the left, we do on the right for x plus 10, right? So this and that will cancel out. This and that will cancel out. And then we'll be left with length. So this can also be written as length is equals to 16x minus 100 over 4 raised to the power of x plus 10, right? So 16x can also be written as 4 raised to the power of something. So when I see this type of a problem, I'm going to try and write it to have the same basis, right? So what I want to have now, I want to have the same base. I want to have the same base, right? So I want to have 4x and something raised to the power of 4 raised to the power of something to have the same basis, right? So this is what I'm going to try and do. So 16 can also be written as 4 squared, right? So that's what I'm going to try and do now. So I have the length, which is equals to 4 squared x, right, minus 100 all over 4x plus 10. Right, so I'm going to say length is equals to 4 raised to the power of 2x minus 100 all over 4x plus 10. Right, so from here, right, we need to write this in terms of x. That's what the question said, right? So from here, I can already see that this can be written as a difference of two squares, right? This. It can also be written as a difference of two squares, right? It's the same thing as having, let's say for an example, because you are used to x, it's the same thing as having, sorry about that. It's the same thing as having x squared minus 100, right? So let's see as a side, right? This is the same thing as having x squared minus 100, right? Which can also be written as x minus 10 and x plus 10, right? It's almost the same as that. So we are going to try and write it in that manner. So we are going to have length is equals to 4x minus 10, 4x plus 10 all over 4x plus 10. So it's not 4x, it's 4 raised to the power of x, right? So in this case, right, so you have a numerator and a denominator that is similar. So you have this and that which are similar, right? So you have that and you also have that which is similar, and which means they can cancel out. So when you have 4x and 4x, it's going to give you, because you have the same basis, right? So you have 4x and 4x, so you add the exponent, it's going to give you 2x. So this can also take you back there. So that and that will cancel out, and then your length will be that. So this is going to be your length. Your length is going to be 4x, what? 4x minus 10 centimeter. This is your final answer. So let's check if we did not make any mistake. It's always important to check if you did not make any mistake. That's how you improve. Okay, so it's fine. We did not make any mistake. Everything is correct. Yes. So let's move on to another question.